Now, how do we set this up? How do we find this? The easiest way to do this is by using dimensional analysis. Pick one you want to do, any one of these. Do you want to do speed? Okay, let's do speed. Okay, so what are we looking for? We are looking for this formula. Okay, so we know speed in a string of a wave in a string depends on, is a function of the tension in the string, the mass of the string, and the length of the string. Now, in order to do dimension analysis, what's step one? V is proportional to T, M, L. And I put alpha, beta, gamma. But remember, T is not time, it's tension. So then I can rewrite tension as, what is tension? A force? Force is newtons, which means it's kilograms, meters per second. So for dimension analysis, can I write it as M, L, T minus 2? Now it is time. So for my dimensional analysis, I'll do V is proportional to M alpha, L alpha, T minus 2 alpha, dot M to the power beta, dot, and L to the power gamma. What should come on this? What should V become? What is V? Yep, meters per second. So my left-hand side should become what? L to the power 1 and T to the power minus 1. Now I can equate powers. Proportionality, M to the power alpha plus beta, dot L to the power alpha plus gamma, and T to the power minus 2 alpha. L 1, T minus 1. Now I can equate powers. What will I get? If I do M, it'll be 0 equals alpha plus beta. If I do L, it will be 1 equals alpha plus gamma. And when I do T, it will be minus 1 equals minus 2 alpha. So this means I can start here where alpha equals a half. Beta equals a minus half, and gamma equals a positive, so it'll be a half. Okay, good. So which equation am I supposed to plug all of these numbers in? All the way at the top or the second one? Good. Let's call this equation, pick a number. 17. Fine. So we plug all of these values in equation 17. I was thinking you guys are going to say cat or a dog, and I'll be like stuck figuring out how to make a cat or a dog. Okay, so what will we get? V equals tension to the power a half, M to the power minus a half, and L to the power a half, right? Which means I can rewrite this as T L over M square root. But that's not quite what I was looking for. Here. This one had a mu in it. And mu was defined as M over L. Do you see that? So how do I make this into a mu? How did I define a mu?
So L over M would be like
1 over mu. Yeah. So that means I can rewrite this as T over mu. Okay, so now the question is, why do I not leave M and L alone? Why do I convert it to mu? What's the physical significance of me doing that? Okay, think about, can you guarantee that the length that you are using is constant throughout? Its mass per unit length is constant if you're going, say, a mile or even a meter. So instead of worrying about the entire mass over the entire length, we just want to consider just the mass per unit length and average it out. That is why instead of talking about total masses and total lengths, we only talk about mass per unit length, whatever that length you may use. Does that make sense? So this has a more practical application. And again, note, when you're doing frequencies or when you're doing periods, start here, right? Just because you are finding some other value, you are not suddenly going to change what things depend on. They will still depend on tension. They'll still depend on mass. They'll still depend on L. The only thing that will change is this side. First, you'll place a frequency. What is frequency measured in? Hertz. What is hertz defined as? 1/seconds. That's the difference. Got it? And then the second time around, if they asked you for period, you're going to replace this with T, and the units of T are just seconds. That's the only change. And it will all fix itself. And I think in the end, you'll get something like T over ML or ML over T. So then just move things around so that you have mu.